So, Philip, what we're going to look at now?
We're going to compare your design requirements to something that we already offer and try and tweak it a bit more to your design, like really, not the internals. We've got all that to figure out now. So,
so this is the sort of the program that you would use to
this is SolidWorks. We do all our 3D designs in here. Its benefits are we generally build a pocket of a unit with no real features, and from that we can add on little features, add on extra, say, drive bays and CD drive bays and things like that. With this design it's quite simple, so we're actually going to work back from a similar design we've got.
Right.
The other benefits are, with this program, we can actually start with a simple drawing and turn it into a quite high quality render. So before the machine's even been manufactured, the customer has a very good idea of what it's going to look like, as well as showing all the options. As we have a lot of the components drawn up in this program, we can show how it would look with this particular foot on it, or this particular colour, or this artwork, and really just get a good idea. And we can, within a millimetre, we can actually replicate what's on this screen to what you end up with in your hand. So this design here is normally a completely headless system. So what we're going to do is we're going to add a switch on it, and as we go along you can tell me what kind of features you would like to add to it or you would like to remove away from it to get it looking how you would like. So I think the first step we'll do, we'll add the switch.
Power switch, So you could have a unit like this one with no switching at all if it was like it was headless.
Which is what this one's originally designed. And we've also got, as you can see, the fins. The particular spec that we're working on today with you does require fins. Other projects may not, so you can actually reduce the footprint, but this one here has had the fins designed.
And the fins are important because that gives you the surface area for the cooling.
Brings up the surface area. As you can see, we've also added more fins on one side. From a top view, you can see that's closer to the CPU area. That's to give maximum cooling in that area, and it actually draws heat away from, say, other chips that may be this side. The other great thing about this, we can give ourselves targets of surface area. I'll quickly show you how we calculate that. So this here gives us straight away a report of the surface area. We can also find out the weight the product's going to weigh by putting in out some calculations of how much the material weighs before it's machined and afterwards, and it even tells us how much waste is going to be created from that machine once it's been milled out. As you can understand, from a billet of aluminium we do lose quite a lot.
But so if I had a specific weight requirement, if it was going in a plane or something, and say I need to be under this weight, you can then calculate what you've got to make it.
And it just means before we go into the main and any, say, real cost is involved with regards to machining and materials, we know everything before. This program does go a step further, and we can actually run simulations of heat and say that area is going to get to this temperature, and we put sensors and it will tell you how hot the other areas on the board, on the chassis itself is going to get. This unit here would now offer all the specs that we're looking for now. There's just some things we can do to make them look a bit unique for your product, for your range. So I don't know if you have any ideas of what you'd like.
I thought maybe if the front was a bit more curved somewhere, so now you feel that it's solid, you can then start to cut away from it.
So a bit something like
just something a bit smoother now.
So what I'd suggest to do from this, if you're happy with the look of the unit now, we'll start to add some components to it.
So these are the type of the feeds and the power switch and
here's an example with this particular switch on it. And this is quite a raised one.
So could you make sort of like a more flush?
We've got other switches with that.
That's good.
Obviously it seems quite bulky, but once it goes in the case it's a lot slimmer than these.
That's got a little power LED ring as well.
It's quite a nice one as well. This one, which we can show you, is actually got brushed aluminium. We'll add some the base and the feet now. So this is a foot I'd recommend. It's quite a nice. It's quite nice for a media sensor. It's actually got a rubber mounting on the bottom. It's made out of plastic with a ring of gold. I think it's real gold. It gives it quite a nice effect.
But if you were willing to pay for it, you could have real gold as well.
Now what we have done in the past with these systems is actually we mount the feet over the hole, so it's another screw less
Yes.
you have to use to open it up. So I'd recommend if we do that.
Yeah.
So they're using all the components that I'd recommend we use. Now if you'd like, we can put together some more realistic looking pictures and to get a good idea of what the system will look like.
Yeah, you can see now that it looks like a finished product now. So it removed the extra fins and round the corners, put the button on there. That looks really good. So once you've got this design now, how can you get this? How much effort does it take then to get this into the to the process of actually start to build it?
Well, we would run a few checks, as I showed you earlier.
Yeah, check the
properties and so
thermal.
on. We'd check we're happy with everything. Then we would hand this on to one of our programmers. Now the programming does vary on the complexity of the product. Now this one, as we've used something similar to what we've got, to get this now machined, programmed to be machined, I would say it would take around 30 minutes to an hour to reprogram it for this design. There's not really much more showing the design. If you're happy with the look of it, you can probably pass this on to one of our programmers. After we've done some quick checks on the thermals in the program, we will pass it on to a programmer and they can start programming it up and give us an ETA on how long it'll take them to machine it.
Right. So yeah, get it to the program. Let's go and have a look at how that's done.
Right, so where are we going now?
Now we're going to go down to the machine room and I'll introduce you to James. He's one of our programmers and he also runs the machine, and we'll start getting stuff input so we're ready to put that design.